Hello everyone, let's get started by going over basic geometry terms. Our first term is a point. A point has no dimension, and so we have to represent it using a dot, and we name points with capital letters. For example, over to the right you'll see point A. Our next term is a line. A line is one-dimensional and extends forever in both directions. Since we can't draw it forever, we represent it by drawing a line with arrowheads on both ends. We have a few options with how to name a line. It can be named using any combination of 2 points on the line. So for example, AB, or we could do it backwards, BA, or A to C. And whenever we write it, we draw a little mini version of the line above those 2 letters. Or you'll see in some cases there's a little cursive lowercase letter at the end of the line, and so in this case we would call it line L. Now this is the first time you're seeing this. You'll see this repeated in a lot of our videos. Pre-AP geometry is required to memorize implied statements, and so then I'll write them below the terms and theorems that they're associated with. So level doesn't have to write them down, but pre-AP does. Next we have a plane. A plane is a two-dimensional object that extends forever in both directions. So you could think of it like the surface of your desk or the floor or the ceiling, even though those planes don't go on forever. You get the gist of the idea. Since it is something that extends forever, again, we have to have a representation of it because we can't draw it, and we represent it using a parallelogram. With planes, we also have a few options for naming. So you can use 3 non-collinear points, so 3 points that are not in a line, and then you name it plane ABC, or you could switch the letters around, BCA, CAB, whichever order, as long as those 3 points cannot make a line. Or sometimes you'll see a little cursive capital letter down in the lower corner, and it's called a script letter. And it's not a point. You'll see there's no dots anywhere around it, and so we would call this plane S. On the left or right side of your paper, I'd like for you to draw a big curlicue like I've done on the screen. Just wherever you have room, make sure it encompasses point, line, and plane, because these 3 together are called the 3 undefined terms. We call them that because they have to be represented. They can't be drawn because they go on forever and some of them have no dimension. Now let's discuss what happens when lines and planes intersect. So on the left I have 2 lines. They're intersecting right here in the middle. So we know lines have 1 dimension. And when 2 things intersect, you have to take away a dimension. So if you go from 1 dimension to no dimensions, that means that right here in the middle we have a point. So 2 intersecting lines meet at a point. And then on the right we have intersecting planes. So planes are 2-dimensional. So if I take away 1 dimension, that means we have a 1-dimensional thing left over. So that must mean that 2 intersecting planes will meet at a line. Our next vocabulary word is a counterexample. A counterexample is an example that refutes or disproves a hypothesis, proposition, or theorem. On your assignment in class tomorrow, you will get a whole table that looks similar to what you see on the screen, and you'll be asked to give an example and counterexample of different terms. So let's do one we just talked about. A point. So what is an example of a point? It wants you to draw a picture of a point. So here I have point P. I have my dot and my capital letter P. Now then you think counterexample. What's counterexample of a point? Well, it's one of the other things that isn't a point. So I could draw a line or I could draw a plane. Neither of those things are a point. Next we have a segment. A segment is a piece of the line. Note that there are no arrows on the ends. We have endpoints. And so when we write this, we write it as we would write a line with 2 points, JK or KJ. The difference is, since it's a segment, there are no arrows, and so then you just have a bar above your 2 letters. A ray is a hybrid of a line and a segment. It has 1 endpoint and then a line that goes on forever in 1 direction. We name it just like the other 2 with 2 letters, L and M, but it's very important what goes above. So if we say LM, then our arrow has to point to the right because the endpoint is above L and the arrow is above M. If we wanted to name it in the reverse order ML, then we would also have to reverse the arrow so that the arrow is still above M and the endpoint is still above L. Next we have opposite rays. Opposite rays are rays coming from one endpoint and extending in opposite directions. So to my right, both rays are coming from B and then extending in opposite direction. Really, this looks like a line with 3 points on it. And when we name them, we'll name AB, again with the arrow above A and the point above B, and BC with the point above B and the arrow above C. Now we have a midpoint. A midpoint is exactly what it sounds like, a point in the middle of a line segment. So the midpoint divides the segment into two congruent segments. It is very important that you notice these two little tick marks between AM and MB. I made them red so they're really obvious. Those are how we mark congruency to show that AM and MB are the same length. We also have a segment bisector. A segment bisector can be a line, a ray, or a segment that intersects at the midpoint. So whatever it is, it's going to hit at that midpoint right there, so it'll cut our line segment in half. Parallel lines is a term you should have heard before. It's two lines that never intersect, and we use the parallel line symbol, just two lines right next to each other, not intersecting. And an extension on that is parallel planes, and those are two planes that never intersect. Collinear points are points that lie on the same line. If you think about the word co-captain, it's more than one person sharing the role as captain. So collinear is more than one point sharing a line. Similarly, coplanar, it could be points, rays, or lines that are all on the same plane together. Congruency is something you should have heard of before. It means equal length, size, or measure. We represent it with an equal sign with a little squiggly above it. There can often be confusion on the difference between congruent and equals, so let's look at two quick examples in segment and angle and see what the difference is. So if I have two congruent segments, that's segment KL congruent to segment MN, versus equality, its length KL is equal to length MN. Notice that these bars disappeared when I went from congruent to equals. And if we look at angles, here we have angle ACD is congruent to angle DEF versus the measure, little m right there, measure of angle ACD is equal to the measure of angle DEF. So overall, the difference between when you use the congruent symbol versus when you use the equality symbol is if you're talking about the object. So like with a segment, that means the bar is the object, versus a measurement. So without the bar, that's a length, and with the little m, that means measurement of the angle. So if you're talking about an object, congruent, measurement, equal sign. And we are finished with this video. Make sure you have all the examples, pictures, definitions, everything that's on the screen needs to be on your paper. See you in class.